top-class problem solver. The goal of this video is to help us learn to analyze the problem and communicate our solution effectively. A sample of a radioactive isotope contains 2.00 by 10 to the 16 nuclei at a given time. The activity at that time is 6.93 by 10 to the 14 per minute. How many nuclei of the isotope are there after 1.00 hour? The problem-solving method consists of 3 steps. The first step is interpretation of the problem. Then we devise a strategy, and then we execute our strategy. The first step of the interpretation is to identify the concept embedded in the problem. The fundamental concept is radioactive decay. The next step of the interpretation is to create the model and represent the model in a diagram. The system consists of a sample of nuclei presented at 2 different times. The sample contains n initial nuclei and n final nuclei. The time interval involved is delta t. The properties of the isotope that may be relevant for this problem are the decay rate r or the half-life t1/2. The third step of the interpretation is to extract the data carefully from the problem. We are told that the sample initially contains 2.00 by 10 to the 16 nuclei. This is our n initial. We are also told that the activity, or the rate of nuclear decay at that instant, is 6.93 by 10 to the 14 per minute. This we will call A initial. Finally, the time interval itself is 1.00 hour. So this is our delta t, and in this problem we are going to choose to work in minutes. The first step of the strategy is to determine precisely what is required. We are required to find the number of nuclei present after 1 hour. This is our parameter n final. The second step of the strategy is to construct the concept map. The concept map relates the parameters that are given in the problem and the required parameter. In order to find the number of nuclei after a given time delta t, we also need the decay rate r for that isotope. This we do not have. R can often be found from the half-life of that isotope. We don't have this either. For this problem, we need to determine R from its fundamental definition. The fundamental definition of the decay rate is the fixed ratio for that isotope of the activity at any given time to the number of nuclei present at that time. The third step of the strategy is to create an action plan based on the concept map. First, we use the fundamental definition of R to find R. Then we use the equation for exponential decay to find the final number of nuclei, n final. The first step of the execution is to follow the steps of the action plan. From the definition of the decay rate R, the activity at any particular time is equal to the decay rate multiplied by the number of nuclei present at that time. Substituting for the values in this problem, we find that our value of R is 0.035 per minute. This is the formula for exponential decay. Using the parameters in this problem, we obtain that the final number of nuclei is 2.50 times 10 to the 15. The second step of the execution is simply to write down and highlight your final answer. We write that after 1 hour, there are 2.50 times 10 to the 15 nuclei. The third step of the execution is to check your answer. When you check your answer, make sure that you state clearly what is required, that you give the appropriate unit, and that the magnitude of your answer is reasonable. We were asked for the number of nuclei, which we have presented as a number. An alternative way of obtaining the answer is to use the half-life. The half-life is trivially related to the decay rate. These are properties of the isotope. The relationship is that the half-life is equal to the ln of 2 divided by r. The ln of 2 is approximately 0.70, so we can say that the half-life is equal to 70 divided by the decay rate when expressed as a percentage. In our problem, r expressed as a percentage is 3.5% per minute. Using the 70 rule, we obtain that the half-life of this isotope is 20 minutes. Our time interval of 1 hour therefore corresponds to 3 half-lives. After 3 half-lives, our sample would have decayed to a factor of 1/2, then 1/2, then 1/2 again, that is to say 1/8 of the original sample size. It is then a quick check to show that our value for the final number is 1/8 the number of nuclei present initially. Here once more is our complete solution. Top class. Here once more are the 3 steps of our problem-solving method. Thank you for watching.